Yeah.
we will need some basic knowledge of trigonometry also, right? But you are aware of those, so we'll not be learning about trigonometry then. Okay. Just a second. Huh? So today we are learning about vectors. Okay.
Yeah.
So what are, just a second, I'll record this for my own. Okay, it's recorded. Yeah. So what are vectors?
Vector quantities are the quantities that require the magnitude, the unit, and the direction to define them.
Okay, very good. So vectors are, can I write it as vectors are physical quantities?
Yeah, physical quantities.
So what are physical quantities, Avika? Vectors are physical quantities.
Quantities that can be measured.
Very good. Which have both
The magnitude and the direction.
and direction.
Yeah.
Right. Very good. So now how to represent, now why vectors are required? So there are certain physical quantities which, there are certain things where we need to have both the properties, right? That is, we need to have magnitude as well as we need to have direction, right?
Yeah.
So let's see how to represent a vector. How do we represent a vector? So symbolically, we can represent a vector. We can represent a vector by an English alphabet with an arrowhead over it.
Yeah.
Right? So by an English alphabet with an arrowhead over it. By an English alphabet with an arrowhead over it, right? Now,
Yeah.
pictorially we can represent it, or graphically we can represent it by a straight line where this end is called as, this is called as, okay, just a second. This kid has joined. So let me ask him, he's in which standard first. So just a second, beta. So Rohan, hi Rohan.
Good evening, sir.
Good evening, Rohan. You are in which standard?
I am 9th standard.
You're on mute.
Sorry. So Rohan, you are aware about basic trigonometric functions, sine theta, cos theta, tan theta and all?
Yes, I am aware, but I don't know the exact approx value of it.
No,
I
no
don't-
worries, no worries. But you know what is sine theta, what is cos theta, what is tan
Yes,
theta. But
that I
that's it,
have
what is
studied.
required. Okay. Can you please switch on your camera also?
Yes, I will.
So Rohan, we are studying a new topic which is called as vectors. Okay. And we are just doing it because this is one of the most important mathematical tool to learn physics, or which we will need to learn physics, right? So we have just a second. Okay. So vectors are physical quantities which have both magnitude and direction. And how to represent a vector? This is how we represent a vector, by an English alphabet with an arrowhead over it. By an English alphabet with an arrowhead over it, right? And pictorially, we represent it by a straight line. This is the tail of the vector. This is the tail of the vector, and this is the head of the vector. Both of you understood this, how to represent a vector, and you just simply write the length as r vector. This is vector r, and direction is usually taken from positive x-axis, in anti-clockwise sense, until and unless it is specifically mentioned, right? So here the direction of the vector is making an angle theta. This is called as theta, right? You're aware of these Greek alphabets, right?
Yeah.
So theta is the angle which this vector r makes with positive x-axis. Rohan, you understood or not?
Yes, I understood, but I don't know about theta. I think so. I have not studied
What
it.
theta is, right?
Yes,
Theta is just an English Greek.
It's just a variable.
It's a variable. It's an English Greek alphabet symbol. You can say a symbol. right?
Okay.
Which we are here using to represent
It's like
the
a
angle.
zero.
No, no,
Zero
no, no,
which
no,
has
no.
no.
नहीं, how to write it? It's simple. You just zero के अंदर there is a
हाँ
small curl,
अब
right?
पढ़ा है बट ये नहीं
X,
पता इसका नाम क्या है.
थीटा बोलते हैं इसको, थीटा, THETA,
Okay.
ग्रीक अल्फाबेट है ये, ठीक है?
Yeah. Okay, sir.
So this is how we represent a vector, right? Now the first thing which comes here is, what is a position vector? What is a, sorry, before that, how to represent the magnitude of a vector. Okay, how to represent the magnitude of a vector. So simple hai, if we have vector A, its magnitude is represented by a modulus sign, or simply you just remove the arrowhead from it. Understood? So if we want to write magnitude of, say, vector P, so you write it as mod of P or simply P without the arrowhead. Understood, both of you?
yeah.
Yes, sir.
Okay. Now comes, what is a position vector? What is a position vector? It's a vector which represents the position of a particle with respect to a reference point. A vector which represents the position of a particle with respect to a reference point is called as position vector. ठीक है? This is what is position vector is. I'll show you how do we write it. So this is the XY plane. This is the XY plane we have. This is the origin of it, right? And we want to write position of this point A and this point B with respect to origin, of course. So this is point A, this is point B, this is origin O. And what we do now is just join O and A. This vector is representing position vector of A with respect to O. This is how I write it. How do I, the tail will be at the reference point. Please pay attention. The tail is at the reference point. Clear? And A is the particle of which we want to write down the position vector. So here again, if I want to write position vector of B with respect to O, I'll draw a vector, a straight line with the tail of the vector at O and the head of vector pointing towards B. So this is RBO. Clear hai? Clear to both of you?
The
Yes, tell me.
x-axis is the vertical. The x-axis
Sorry,
is
my
the
bad. My bad. This is y-axis and this is x-axis. Okay.
Yeah. So now the y-axis is a vertical displacement.
No, we cannot say it is display. We are not talking about displacement. We are talking about position, right? So with respect to O, how to write the position of A? How to draw the position vector of A? For example, both of you look at your left hand bottom corner of the room. Both of you look at, just identify that bottom corner. Identified? Left hand bottom corner of the room.
Yeah.
Now, if you want to draw a position vector with respect to you, position vector of that bottom corner with respect to you, what will you do? Just stretch your left hand, stretch your left hand, and the hand is pointing towards, the fingers are pointing towards that left hand bottom corner. Imagine it is touching it.
I
This
understood
vector.
that part, but
Okay.
like, is this only for the position, or like, is this basically for the displacement, right? Like the distance or the displacement.
No, we
The
cannot call it as
position,
displacement or distance. It is simply
basically
denoting the position. It is
physical
simply,
position of
yes, it is simply denoting the position of a particle. If it
Okay.
will, if we want to write displacement, there is a different thing. It will be a different method to write the displacement. Understood?
Yeah.
Rohan, understood?
Yes.
Yeah. Ranjita, you are in which standard? Can you please switch on your video and tell us which you are in which standard?
I am in 10th standard.
So you are aware about trigonometry, right?
No, they haven't yet taught us.
You don't know anything about trigonometry, sine theta, cos theta, tan theta, nothing?
Yes, I know that.
You know that, but that's it. That is what I require. So can you please switch on your camera also? Okay. So these are position vectors. Now, if I ask you to write, so Ranjita, we are learning vectors. I'll give you an overview of it when I'll explain. Let me explain this first to all of you. So if I want to write position vector of A with respect to B, if I want to write position vector of A with respect to B, how will you draw it? Where will what is the reference here? A or B? Rohan, tell me what is the reference here? A or B?
A.
No, we are writing position vector of, how will you read it? Avika, how will you read it?
It'll be the position of A with respect to B.
We are writing position vector of A with respect to B, right? So here, which one of these two is a reference now?
B is a reference point.
B is the reference, right? Because with respect to B, we are writing. Now we are writing position vector of A. So how will we write it? The tail of the vector, how will we draw it? The tail of the vector will be at B and the head will be pointing towards A. We write this as position vector of A with respect to B. Understood or not, all of you?
Yes, sir.
Ranjita, you understood this?
Yes, sir.
Okay, good. So this is all about position vector. Now comes unit vectors. Now comes unit vectors. So what are unit vectors? Unit vectors are unit, just a second, huh? I'll make some room for me. Yeah. So unit vectors are vectors which have their magnitude, which have the magnitude as 1. Right? So pay attention, all of you. Now, conventional unit vectors are, okay, first of all, what is the usage of it? So they are used to indicate the direction. Okay, they are used to indicate the direction. Conventional unit vectors are I cap, J cap, and K cap. I'll tell you what is this I, J, and K. Along X, Y, and Z axis respectively. X, Y, and Z axis respectively. I cap, J cap, and K cap. Understood? Now, what is a unit vector? The magnitude is equal to 1. Okay? And it is represented by a cap. It is used to indicate the direction. So pay attention, all of you. Now, this is the XY plane we have. This is X axis and this is Y axis. So unit vector along X axis is I cap. Unit vector along Y axis is J cap. And there is a different three-dimensional thing. We call that direction as Z axis. So this is unit vector along Z axis and this is K cap. I hope this I cap, J cap, and K cap is clear to all of you. Yes or no?
Yes, sir.
Avika and
Yeah.
Yana,
Yes, sir.
Ranjita. Okay. Now, so why cap? So cap is this sign is called as caret sign. This sign is called as caret sign. CARET. Okay. But we call it as cap usually. In common language, we can call it as cap. We call as cap, and everybody will call it as cap. Okay. Now, what happens is this has a unique identity that whenever we put this arrow sign upwards in the or caret sign in I or J or K or any symbol, right? That means that it is a unit vector. For example, if I put it above A, so the magnitude of A is 1. If I put it above P caret or P cap, it is the magnitude is 1. Got it, all of you? Now, the direction of x-axis is I cap, the direction of y-axis is j cap, and direction of z-axis is k cap. So if a man walks from this point, origin, to 3 units in this direction, okay, if he walks from 0 to 3 units in this direction, so its magnitude is
3.
3. Very good. And meters, and what is the direction of it? It is pointing towards x-axis. So let's write this as A. So position vector of A with respect to O is how much? 3 meters I cap. I hope all of you understood this. Yes or no?
Yes, sir. Sir, I had a doubt.
हाँ पूछो.
Sir, is there any SI unit of any vector in any axis?
Sorry.
The SI unit of any, like you have written 3 meter I
So
cap.
in this case, the physical quantity is position, right? Position
sir.
is measured in terms of length only. Yes
Okay,
or
sir.
no? Position is length only, na? So it is meter is what represents the length. So SI unit of this particular vector is what?
3 meter.
Meter. That's it.
Are unit vectors only used for the position, or can they be used for like terms like velocity as well?
Velocity also, because they indicate the direction. So if an object is moving with a velocity of say 4 meters per second along positive x-axis, we will write 4 meters per second I cap. That's it.
Okay.
Understood? Ranjita, understood?
Yes, sir.
Okay, all of you, note it. Please make a note of it. All of you, copy it. And once you are done, just type done in the comment window or tell me done. Huh? Just let me know when you are done, okay?
Okay, sir.
Rohan, what's your full name?
Rohan Kacha.
Okay. And Ranjita, this is, what is your full name?
Khushi Aras.
Acha, you are Khushi. So,
Yes, sir. Ranjita is my mom's name.
okay, I'll just, these kids are joining late. So Shanmukh and Anvi, we have started. Both of you are in which standard? Done? Hello?
Wait a second, sir. Only a little
Sure,
bit.
sure.
Yeah, hello. Sir, can you hear me?
Yeah, now I can hear. What's your name, dear?
Swarit.
Swarit. Okay,
Yeah.
Swarit. So why did you join late?
Sir, my dad didn't tell me about the class.
Acha. So you are in which standard, Swarit?
I'm in ninth.
You are aware about trigonometry?
No, not yet.
Okay. So just go through this slide once, right? We are learning vectors. So what are vectors? They are physical quantities. I have just discussed the definition. Okay.
Okay.
How to represent a vector. I'll share the recording of this link with all of you so that you can go through it once again. Okay. But
Okay.
again, for that you need to first of all, पर कहाँ भेजेंगे हम लोग तुमको? All of you send me your WhatsApp number here. Write your WhatsApp number in the group, all of you, so that we'll send you a link of this recorded session. Okay. You can send it directly to me. WhatsApp number, huh? Okay. Done? Noted?
Yes, sir.
Okay.
Yes, sir.
So we have discussed about vectors, which are, what are vectors? Are physical quantities which have both magnitude and direction. Represent a vector, we can represent it by an English alphabet with an arrowhead over it. How to represent the magnitude of a vector? Simple hai, we draw a mod sign, vector of A, or we simply remove the arrowhead. This thing is called as arrowhead, right? This thing is called as arrowhead. Okay. Now, physically, it is represented, graphically, it is represented as a straight line with a tail and an arrowhead. Here, this is the magnitude of it, and this is the direction of the vector. Usually, direction is measured from positive x-axis in anti-clockwise sense. Then comes position vector. It's a vector which represents the position of a particle with respect to a reference point. This is called a position vector. So how to draw it? If I want to write position vector of A with respect to O, we simply join the points O and A, for which the tail of the vector will be at O and the head of the vector will be at A. I hope this is clear to all of you. Yes or no? And then comes unit vectors. Unit vectors are vectors which have magnitude as 1. Okay. Conventional, by conventional unit vectors, we mean that all across the world, whenever they will say I cap, we will understand that it's a unit vector along positive x-axis. All across the world, when they will say k cap, that means the vector is pointing along positive z-axis. I hope this slide is very clear to all of you. Please say yes or no.
Yes, sir.
That's
Yes.
great. Thank you so much.
Yes, sir.
Very good. So now let's discuss about addition of vectors. See, why we are studying vectors is very it's a very obvious thing, because vectors and calculus, you will not be able to learn physics in a more lucid, more clearer way if you don't know vectors. Okay? So this is the most essential part or most widely used topic of maths. So now comes addition of vectors. Addition of vectors. So now how to add two vectors? So, but before I move with the addition process, I'll tell you this. Let's see this statement. A vector never changes. Please pay attention. It's very easy to understand, right? A vector never changes if it is moved parallel to itself. If it is moved parallel to itself. So what does that mean? All of you, please pay attention. I have this vector here, right? And if I move this vector parallel to itself, see, has it changed? It is pointing along the same direction. Yes or no?
Yes, sir.
Its
Yes, sir.
magnitude also has not changed. The length of the vector also has not changed. So the vector remains as it is. I hope this is clear to all of you. So a vector never changes if it is moved parallel to itself. Now, remember this. We have two different vectors now, and we want to add both of them. We have two different vectors, vector A, and this is vector B. So we want to add these two vectors. Now what we will do is, always remember that whenever we add a vector to another vector, we get a vector only. Clear hai beta sabko? All of you?
Yes, sir.
Whenever we add two vectors, we get the third vector. It cannot be like that we are adding two vectors and get a different quantity. That is a scalar quantity. I hope this is clear to all of you. Also, the dimensions of A, B, that is the units of A and B, should be same, and obviously C will be of the same unit. So if we are adding meter and meter, we will get a meter only. If we are adding meter per second, we will get a meter per second only. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Okay. समझ आया नहीं आया बेटा सबको? I heard only two voices. Khushi, Avika, Rohan, Shammukh, Swarit.
Yes, sir.
Okay.
Yes, sir.
So now if I want to add these two, if I want to add A and B, so what I will do is, I will keep any one of them as a reference vector. So which one of these two you want me to keep as a reference? Tell me, A or B?
A.
Reference matlab we will not be moving it, right? So we are fixing A here. Done. So now what we will do is, we will move vector B parallel to itself such that the tail of B coincides with head of A. Clear? So this is vector B. I hope all of you are clearer in this. Yes or no?
Yes, sir.
Now we are left with a tail and a head. So this is how we draw these two. Join the free head and tail. You get a vector C here, which is summation of A and B. So summation of sum of A and B is given as C. Now, understood till this point? Yes or no, all of you?
Yes, sir.
Okay. Now comes the fact that what if will the result be same if I add B and A? B plus, if I'll do B plus A, will it be equal to C? So let's do it and check. What we will do is, now take B as a reference vector and move A parallel to itself such that the tail of A coincides with head of B. Okay. And now join the free tail and free head of both the vectors. So this is again vector C. Check karo, yes or no? All of you.
Yes,
Yes,
sir.
sir.
So B plus A is equal to C. Got it? And A plus B is also C. What is this property called A plus B is equal to B plus A?
Commutative.
property.
Very good. This is commutative property.
Is there any way to add this in a non-graphical method?
No. You will learn vector mathematics in 12th standard, which is only maths of vectors, right?
Okay.
So you have different set of rules to add and subtract and multiply vectors. Got it?
Now, how do we, for example, if here A is 5 and B is 2, then what will C be? Like, how do we calculate C?
Sorry, can you please repeat?
If A is 5 and B is 2, then
Mhm.
what will the value of C be?
The challenge is here you have not mentioned the direction of A and B.
Okay,
You have
so
to mention it, right?
A is, okay, same things. Same thing. A is east, B is northeast.
Okay, so this is A,
The same diagram.
this is A is east, right?
Yeah.
And B is northeast. So now when the vectors are given like that, you have to first resolve the vector into its we'll discuss this in vector addition. Abhi to shuru hi hua hai na? We'll discuss it. First, you should know how to find components of it and then add it. I'll tell you, don't worry.
Okay.
As of now, this is the way we add it. We move a vector parallel to itself if we are adding only two vectors. So this becomes a triangle, right? When we introduce this vector C, it becomes a triangle. The triangle is completed. So this is also called as triangle law of vector addition. Triangle law of vector addition. Yes or no?
Yeah.
Right? All of you copy, note it down first, and then we will move ahead with next part. How to find components of vectors. Do it quickly.
And if it's in the same direction, then we can just add it.
Yeah, then we can just add it. I'll teach you everything. Don't worry. अभी बताता हूँ बेटा, हाँ? यहाँ तक समझ आया ना पर?
हाँ.
बस. Shammukh, you understood or not?
Yeah, a bit.
You are in which standard, Shammukh?
My eighth.
हाँ, so this will be, but यहाँ तक तो अभी you will understand it. इसमें तो कुछ नहीं. Why are you late?
Yeah, I joined many links, but none of them the meeting started.
Sorry?
I joined many links, but in them none of the meetings started.
Acha. Some other link you must have tried.
Yes.
Got it. No worries. I'll send you the recording of this. You'll watch it, huh?
Okay. Yeah, okay.
You have shared your number here, right?
I'm sharing now.
All of you share your WhatsApp number so that you can receive the link of this session. See, today's objective is very clear. I just want you to understand how a formal lecture happens in online format, right? And just to make you comfortable that if you learn this way, is it just to, you'll have to judge yourself that whether you are comfortable with this entire model or not, the way of teaching or not. If you are okay with it, then it will be help you to get a clear decision.
Done, sir.
Okay. Once you are done, just let me know or type done in the comment window. Okay.
Yeah, I'm done.
Okay.
sir.
Done. Rohan, Khushi,
Done, sir.
Avika, Swarit.
Yeah, sir, done.
Okay. And Shammukh, done? Shanmukh? Okay.
Yes, I noted this now.
Okay. So this is the introduction to addition of vectors, right? Since it forms a triangle, that's why we call it as triangle of addition of vectors. Now let's try to understand how to resolve a vector. How to resolve a vector into its components. Now, what do you understand by this? Pay attention. Huh? Do you have sorry. So do you have your pen in front of you? All of you have? What do you do is
Yes, sir.
just open your pen now. Can you dismantle it? All of you, can you dismantle your pen
Yes, sir.
like this? So you are dismantling, these are the components of your pen, yes or no?
Yes, sir.
And if you reassemble it, you get the pen back, right? So that is
Yes, sir.
how we will resolve a vector into its components, and we will add them together, add them back to get the vector itself. Clear?
Yes, sir.
So how to resolve a vector into its components? Now pay attention. So here we have y-axis and x-axis. Okay. Now this is the vector which we have. This vector is, let's call this vector as our friend r vector. Okay. Now the vector is making an angle theta with the horizontal or with the x-axis. Okay. Now pay attention. If you want to find its x component, if you want to find its x component, right? X component. But before I do that, let me write this thing. A vector can be resolved. We are talking about a planar vector, right? All of you understand what is planar vector? You guys understand what is planar vector?
No, sir. I
No?
don't.
A planar vector is which lies in a plane. A planar vector is which lies in a plane, right? So a planar vector can be resolved. A planar vector can be resolved along any two mutually perpendicular and coplanar lines with it. Okay. Do you understand what I am writing here? A planar vector can be resolved along any two mutually perpendicular and coplanar lines with it. So how many, if this vector r is lying in the xy plane, how many mutually perpendicular lines are here in this plane? Please tell your answers. So Avika, how many lines are here? How many mutually perpendicular pair of lines are here?
There's only one pair.
Okay. Rohan,
Sir, I don't know what is coplanar lines.
coplanar matlab which lies in the same plane as the vector.
Oh, sir.
So if the vector r is lying in the xy plane, then xy lines are, xy axis are coplanar lines. Right?
Okay.
I'm just asking how many mutually perpendicular pair of coplanar lines can be drawn in this xy plane.
One, sir.
Okay.
Sir.
One.
Can be drawn. There can be many that can be drawn. Infinity.
Obviously, there are many. Right?
But you asked how many are there right now?
No. I asked how many we can draw.
Okay.
Okay. So this is one set of lines. If I have asked you how many are there, then there is only one pair, but we can draw infinite number of pair of lines. Yes or no?
Yes, sir.
Which are perpendicular to each other. Swarit, understood? Khushi, Swarit, Arav. Arav, why are
Yes,
you late?
sir.
Shanmukh.
Yes.
Yeah, sir.
Okay. So there can be infinite number of pair of lines which are perpendicular to each other, which can be drawn in this plane, right? Now, So a planar vector can be resolved along any two mutually perpendicular and coplanar lines. So in this case, we want to resolve it along x-axis and along y-axis. Now, what is this resolving? It is actually finding the shadow of, vector R. Imagine it to be an opaque line. Avika, you're feeling sleepy?
No, no.
No. Okay. So what we will do here is shadow of this opaque line on x-axis. So you are just incidenting light from the top, right? And you want to find the shadow. So how will you find the shadow here? Drop perpendicular from the tail of the vector on x-axis. Drop perpendicular from head of the vector on y-axis. The shadow of tail will be a tail. The shadow of tail will be a tail. The shadow of head will be a head. Understood, all of you? So this is how we can find the component of vector R along x-axis. So we write it as R vector x. Understood? Avika, Rohan, Shanmukh, Swarit,
Yes, sir.
Yes, sir.
Khushi.
Yes, sir.
Okay, great. Now, similarly, once we have found the component of it along x-axis, we can similarly find its component along y-axis. So how to do it? Just drop perpendicular from tail of vector R on y-axis, from head of vector R on y-axis. And this is it. This is the tail, this is the head, shadow of head and tail. And you draw the vector now. So this is the vector. Got it?
Yes, sir.
Yes, sir.
Okay. So this is vector R. This is vector R, Y. Okay. Now, we want to prove that if we add these two vectors, if we add the components, will we get the vector back? That is, if I add vector Rx and vector Ry, will I get back vector R? So check karte hain. So what we do here is, we will move vector Rx parallel to itself such that it reaches this point. And similarly, we add vector Ry to vector Rx like this. Yes or no?
Yes, sir.
So are we getting R vector? Following the triangle law of addition of vectors, you can see here that the tail of Ry is on the head of Rx. Yes or no?
Yes, sir.
The tail of Ry is on the head of Rx. And we can easily see here that Rx and Ry are adding up to give us vector R. So this is how we can prove that these are the genuine or original components of vector R. Understood or not? Avika,
Yes.
Rohan, Khushi.
Yes, sir.
Yeah, but then that does not make sense because if you add both of them, that would not be giving that slanting, right? Like, even if you put
It is giving it, see? R vector is slanted at the same angle.
yeah, but then like if you use normal maths and if like you know that
We are not using normal maths. We are using vector addition.
okay.
There is
Okay.
still I cap and j cap left. So we will be using, I'll teach you how to do that. So just wait for a few seconds. But following whatever we have learned today, did you understand it or not that when Rx and Ry are added, we are getting that R vector following triangle law of addition of vectors? In the previous slide, we have just learned it. Yes or no?
Yeah.
We are following that only. So following that, you are getting it. Yes or no? बस अभी इतना ही करते हैं बेटा, अभी आएगा सब, ठीक है? Don't worry. So can I write vector Rx as, what is the magnitude of Rx? Simple Rx. In which direction it is pointing towards? I cap. Simply Ry vector can be written as magnitude is Ry and its direction is j cap. Yes or no?
Yes, sir.
Right? Now, all of you are aware about right angle triangle. Okay? And you know trigonometry. You know trigonometry, right? So this is vector Rx, this is Ry, and this is R in this right angle triangle. Say yes or no.
Yes, sir.
Yeah.
Avika, Rohan, Khushi, Arav, Swarit, Shanmukh. Okay. This angle is theta. Understood? So cos theta. What is cos theta? Those of you who understand trigonometry, this is Rx over R. And what about sin theta? Sin theta is Ry over R.
RY by, yeah.
So from here I get Rx as what? R cos theta. And from here we get Ry as R sin theta. Understood or not?
Yeah.
Yes or no? Now, so if you are given, now what have we achieved from here? Pay attention. If we know magnitude of vector R and its direction, if we know magnitude of vector R and its direction, we can write its components like this: R cos theta and R sin theta. Understood? Its components along x-axis and y-axis are given as, in this case, it is R cos theta and R sin theta. I hope all of you understood it. Yes or no? So Rx vector is nothing but it's R cos theta I cap. Its magnitude is R cos theta. Ry vector is R sin theta j cap. Since R and theta are known to us, that's why we have to write all the components in terms of the known values. Understood?
Yeah.
Any doubts till this point? Chalo, copy it quickly. Please make a note of it.
I have a doubt.
Pucho.
Okay, so just as an example, okay,
Mhm.
let's vector over here as displacement, okay, and
Let's.
let's take the vector over here as displacement,
Okay.
okay, and let y-axis be the vertical displacement,
Mhm.
and the x-axis is the horizontal displacement, okay.
Mhm. Mhm.
Now R is the quantity that is moving slanting, right?
Mhm.
Basically moving slanting.
In the xy plane.
On the xy plane, yes. This is moving slanting, right? Now, now without using the addition technique that you have shown us, we just have to draw the R as a hypotenuse of any right angle triangle, okay? And then if you have to calculate the hypotenuse, wouldn't it be the addition of
Then I didn't get you. What did you say? You have to
we
take
have
R as?
the hypotenuse of a right angle triangle?
Okay.
Okay, then wouldn't R be the addition of the squares of the two vertical displacement?
R vector will not be the addition of squares. R vector will not be. The magnitude of R will be square of Rx square plus Ry square.
Oh, okay, okay. The magnitude will be that, right?
Ha, the length is R square, right? The length is R. R
Ha.
vector is different. R is different. Magnitude is given as root of Rx square plus Ry square. Ka root.
Ha.
Understood?
But how is R vector different? Only the direction is there, no?
Obviously, it's a hell lot of things. See, you are moving 10 kilometers per second northeast and you are moving 10 kilometers south. It's different or not? You will reach two separate places.
हाँ लेकिन but magnitude तो same है ना?
हाँ तो क्या हुआ? 10,000 आदमी भाग सकते हैं अलग अलग डायरेक्शन में 10 मीटर पर सेकंड से, उससे क्या होता है? पर सब अलग अलग डायरेक्शन में पहुंचेंगे ना. मैग्नीट्यूड सेम होगा, उससे क्या फर्क पड़ता है? होगा. It's a length. Length will always be the same. Length will not change, but direction remains different. And that is why the vector importance is here. ठीक है? उसका importance यही है कि उसके पास direction है. A mass of 5 kg kept in any direction will be a mass of 5 kg. But a velocity of 5 meters per second in east is different, west is different, north is different, south is different.
Yeah, yeah.
So that is what is making the difference here, the direction. ठीक है? Once you're done writing it, just let me know.
Done, sir.
Okay. आरव स्वरित हो गया? षणमुख,
Yeah, sir.
Yeah.
खुशी, खुशी नहीं है. So if you're done, just write done in the comment window. Okay, Avika is done. Chalo. So what have we done in this part of the slide is we have found how to resolve a vector into its components. And we have also tried proving that if we add the components together following vector law of addition, we get the vector back. Now, I'll teach you one more thing for this session. If we have a vector like this, pay attention all of you. This is XY plane only. We are learning only two-dimensional vectors today. So we have this man who is moving from origin. Pay attention, huh? Who is moving from origin to, say this is 1, 1, 2, and 3. So 3 meters at point O. And then he takes a left turn. And travels for, say, almost 4 units. And travel for almost 4 units, right? So this is 1, 2, 3, and I'll make it 4. Anji, this is 4. Now pay attention. So this man has moved, he has reached this location. Okay, say this point is B. Now, can you write position vector of A? All of you, pay attention. Can you write position vector of A with respect to O? So this is how we can write it, right? And this is, let's write it as RAO, and this is 3 I cap meters or 3 meters I cap. Say yes or no.
Yes, sir.
Yeah.
Okay. And if we move from A to B, this is position vector of B with respect to A. And what is it? It's 4 meters J cap. J cap is the direction of this vector pointing along Y axis. Yes or no? Swarit, Rohan,
Yes.
Shanmukh,
Yes.
Avika, Arav. You are in which standard, Arav?
9th.
Sorry?
9th.
I didn't get you. Can you please be a bit louder?
9th.
9th. Okay. Chalega. So now, what is the displacement of this man with respect to the original position? The displacement. Haan, bolo, bolo.
OB.
It will be OB. Very good. So this is the displacement of man, right? So can I write it as RBO or simply displacement of man? Displacement is the shortest distance between 2 points, right? So here, can I write displacement S vector as, can I add these two, RAO? Can I write it as addition of RAO and RBA? Yes or no, all of you?
Yes, sir.
And what is the magnitude of this? It's 3 meters. This is 3 meters I cap plus this is 4 meters j cap. Yes or no, all of you?
Yes, sir.
Now, this is the vector, this is the displacement vector, right? Now, how
Yes.
to find its magnitude? Pay attention. How to find magnitude of vector S? This is, take it, draw the right angle triangle. Okay, OAB. This is O, this is A, this is B. This is 3, this is 4, right?
Yes, sir.
This is the hypotenuse of it. So S is what? The magnitude of S vector, that is S is equal to 3 square plus 4 square. And this is 5. Yes or no, all of you? Hello.
Yes, sir.
Yeah.
Okay. And the direction which it makes with positive x-axis in anti-clockwise sense. Let's say this angle is say phi. This is some angle phi, right? So can I write tan phi as 4/3? Yes or no, all of you?
Yes, sir.
So this is the angle, phi is the angle which this vector makes with positive x-axis measured in anti-clockwise sense. So here, to just write this vector, to find this phi, it's tan inverse of 4/3. I hope you are, I am aware that you are not aware about inverse functions of trigonometry, but you can write it, you can understand it like this. If I ask you which angle has its sine as 30 degrees, sorry, which angle has its, sorry, just a second. What is sine 30 degrees? You are aware of it, that it is 1/2, right?
Yeah.
If I ask you which angle has its sine as 1/2, which angle has its sine as 1/2? You will obviously say it is 30 degrees, right? So that is how sine inverse is read as or used as. Sine inverse of 1/2 is equal to 30 degrees. Say sine inverse of 1/√2. You are aware of it. It's 45 degrees. Yes or no? Sine inverse of √3/2 is 60 degrees. You are aware of it. So that is how sine inverses or tan inverse function of trigonometries are used. All of you understood this part or not?
Yes, sir.
If a vector is given as a sum of its x and y components, this vector is called as x component of displacement vector. This vector is called as y component of displacement vector. Got it?
Yes, sir.
Good. So please copy it quickly and we are done for the day then. Swarit, you understood?
Yeah, a little bit.
What is the thing which you didn't understand?
Sir, in the first slide,
The first
what
slide
I
or
just
the previous slide?
I just have a small doubt. What is the angle between the OB and OA? What is it called?
Okay, theta. That symbol is called as theta. You're talking
Okay.
about this symbol, right? This is a
Yeah.
Greek alphabet. This is called as theta. That's it.
Okay,
जैसे
okay.
ABCD होता है ना बेटा, वैसे ये theta है. ठीक है?
Okay.
This is phi and this is called as phi. PHI.
Okay, sir.
ठीक है?
Thank you.
हाँ. Okay. चलो तो आज के लिए इतना ही था. I hope all of you have understood it. Rohan, Avika, Arav, Swarit, Shanmukh.
Yes, sir.
You guys understood whatever we learned today?
Yes, sir.
So this is how the formal classes will be done. Okay. You have already given me your WhatsApp number. I'll send the link, the recorded sessions link on your WhatsApp number. Okay. You can go through it once. If you have any doubts, you can connect to me. Okay. Avika, Rohan, Arav, Swarit and Shanmukh. Okay. So thank you so much, kids, for joining in.
Yeah, thank you, sir.
Thank you.
Sir, I
Bye.
have one small doubt. Sir, like you have given in this figure, like A/O. So in this, O is the tail.
Reference point.
Reference point, yes.
Hmm.
So, sir, O is the tail and
Huh.
A is arrowhead, right?
A will be pointing, sorry, arrowhead will be pointing towards A.
Okay, sir.
Okay.
Okay, sir. Okay, sir. Thank you, sir.
Thank you.